Hi, in this video I'm going to show you guys how to sketch the graph of your f of x and your first derivative f prime x given this graph of second derivative. Okay, let's get started. So before we do that, we need to kind of think about this to ourselves. My second derivative graph, let me close that. My second derivative graph tells me, what does it tell me? It tells me two things. Right? Number one, this is annoying. Number one, that's the concavity. Right? When we learn about second derivative test, the second derivative graph can tell me the concavity of my original function. Concavity of my original function. Sorry about the bad handwriting. I'm using a mouse. Now, the second derivative graph also tells us the slope of my f prime, slope of my f first derivative. Okay, and similarly, this concept of slope is very similar to, say, what does my f prime tell me? Right, my f prime tells me the slope of my f of x. Okay, so now that we have this knowledge in our head, we need to sort of keep that in mind. Okay. Alright, so let's get started. So if I look at my second derivative graph, we have 2 points that are pretty special, because my second derivative graph tells us two things: the concavity of my f of x and the slope of my f prime x. So you sort of need to decide which one do you want to do first. Which one, do you want to draw the f of x first, or do you want to draw the f prime x first? In fact, we should do our first derivative graph first, and then my f of x last. Okay, so let's do that. So, which means I'm going to be looking at this point right here, the slope. When x is -3, and then x is x is 2. My slopes at those 2 points are zeros, right? So, and also before -3, everything is negative, which means my first derivative is decreasing. From -3 to 2, everything is positive, which means my f prime is increasing. And then passing after x equals to 2, everything is decreasing again. So from decreasing to increasing, I'm gonna have a minimum point. Excuse me. I'm gonna have a minimum point. So I'm gonna put a minimum point there. My minimum point could be there. My minimum point could be there. In fact, my minimum point could also be there. Right. The reason why I put it down there is because what if I have a maximum later on? My maximum point. If I have my minimum point here, I'm giving myself a bit more space for my maximum point, right? So where's my maximum point going to be? It's going to be here, because everything's increasing, and then everything's decreasing after that. So I'm going to have a maximum point here. Okay. I hope you guys understand the steps, the rationales. I'm putting those 2 points down, and just keep in mind that I chose to put this minimum point here because I like it. That point could be here, that point could be there. But what's important is it has to be on this -3. It must have this -3 x coordinate. Okay. Same thing for my maximum point. My maximum point can be all the way up there if I want to, but or maybe a little bit closer to the x-axis if I want it to be, but it must be vertically aligned. It must have a 2 as the x coordinate. Okay, so let's try to sketch this. I'm gonna use red. Just continue to use red. So everything. If you like, if I go back to my second derivative graph, everything here is negative, which means the graph of my first derivative is decreasing. So I have 2 options. Decreasing means I can go like that, or I can go like this. Right? They're both decreasing. So which one I'm going to use? I'm going to use this. Oh, sorry. I'm going to use this one. Okay, you'll see why I keep on deleting those points later on. The maximum, and you're going to come back down. Okay, so this is my f prime x. Okay, let's see if it makes sense. Let me just write this down. This is my f prime x. Okay, so I have a minimum point there, and that's why I have this slope of 0, right? That makes sense. And everything here before that, everything is negative, which means it is constantly decreasing. So you can see that everything on the left of my f prime x graph has a negative slope. Now from -3 until 2, it should be everything for my second derivative graph, everything is positive, which means everything here is increasing, keeps on going up. It's going to go up until maximum point, and then it's going to decrease again. Right? It's going to decrease again. Now you might have noticed at the very beginning, why did I keep on erasing this part of the graph? Because of this point right here. I was trying to sort of get a better x-intercept for my f prime x, right? So here I have an x-intercept at -4 and 4. So you actually had the choice at the very first time. If you rewind the video, I think I cut my x-intercept was somewhere there, which was not very good. I mean, it's okay, but I just need to be aware of it, because later on, when we sketch the graph of my f prime x, again, I need to consider that vertical alignment. Okay. So what about concavity? Right. Just now we discussed about concavity too. So what's wrong with, say, this graph? But this is decreasing. What's wrong with, say, maybe something like this? And they're increasing, right? So I'm going to increase like that. And then decrease, I'm going to decrease like this. What's wrong with that? In fact, there's nothing wrong with that. But when we are drawing, when we are making sketches, we're trying to sketch the curves, we try to make it as smooth as possible. Try to avoid sharp corners. Okay. So if you look at this blue graph, this could potentially be your f prime x too, because I have a minimum point there. Everything is decreasing, right? So this, everything on the left hand side, this is all negative slope. So that makes sense. From minimum to maximum, it is increasing. It is always positive, right? It is always positive. And after this maximum point, everything is decreasing again, right? But when we are making curves, we try to avoid sharp turns. And we're trying to make the curve as smooth as possible. So when we get to this minimum point, we sort of hit the minimum point and then we turn right away. Same thing here. We hit the maximum point and then we turn right away. Right? So those are pretty big curves. And also, if you think about it, my f double prime, this sort of looks like a x squared, right? It's like a parabola-ish. So it would only make sense if my f prime x is sort of like a cubic function, right? So when we sketch our when we sketch our original function, our graph should be sort of to the power of 4, a polynomial with the power of 4 graph. Okay, so just keep that in mind. So right now, the red color f prime x makes sense. Now let's sketch our f of x. Now for f of x, I'm going to use green. Okay, So here and now also I'm going to use my f prime x, the one that I just drew. Look at my zeros. So this is my zeros, which means I might have maximum or minimum for my f of x. And then here I have another 0, right? And then here I have another 0. So I have three relative maximum or minimum. We'll find out. So this is from positive to negative. So everything here is increasing, and then up passing through that extrema, everything is decreasing. So we have a maximum point. So I'm going to put a maximum point over here. Again, this green point could be all the way up there. It could be all the way down there, but I just like it to be there. So everything on the left hand side is going to be increasing, and then decrease, 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 decrease until this point right there. Okay, maybe I should make this point blue. Alright, so everything increasing, and then decrease, 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 and then hit this. We're gonna have another maximum minimum here. Everything is minimum. Everything is negative, which means decreasing. Everything here is positive, which means increasing. So decreasing, increasing, I'm gonna have a minimum point. So let me put a minimum point there. Again, this point could be all the way down there if you want to. Okay, as long as it's on the negative side. Sorry, as long as it is below this maximum point. This green point, this minimum point can be here, just a little bit lower than the maximum. That's fine. But just for now, I just put it there. Now over here, this is everything is positive before that, which means increasing. Everything is negative later after that, which means decreasing. So increasing, decreasing. I'm gonna have another maximum here. Let me just put it there. Okay. Now my let me maybe label them. This is max. This is max. I recommend you guys to label the maximum minimum points in pencil, and maybe we need to erase them later on. Okay. Alright, so we sort of, our curve is going to come up, hit the max, come down, hit the min, and then come back up again, hit the max, something like that. Alright, so this is our last step. We need to consider our concavity. So for concavity, we are going to look at our second derivative graph. Everything before -3 is negative, which means if I look at my green, which is my f of x, everything should concave down. And concave down until -3, right? Until -3. So I'm gonna say, so we need to sort of keep in mind two things: the concavity and the increasing, decreasing. So from this max to this min, it is always going to decrease, but from this point here until -3, it is concave down. So maybe something like that. And I just feel like stopping there. If you like, you can do this if you want to. Alright, but just to make it smooth, I'm going to stop here, and then after that point, everything should concave up, right? Because this is positive. So I'm going to concave up, but at the same time decrease and hit my minimum point. So here I have like a point of inflection, basically. POI. Now on the left hand side, everything is concave down, so this part is easy. Just sort of do that. Okay. Let me just make that prettier. Okay. Okay, so now let's see what we do from this minimum point. So we need to get from this minimum point to that maximum point. But at the same time, we need to think about, and so from this minimum point to that maximum point, everything's obviously everything's going to increase, but we need to keep in mind the concavity. So from this point onwards until the 2, everything is positive in terms of my second derivative graph. So this should concave up, concave up, concave up. I'm going to stop there, or if you don't want, I can stop maybe somewhere here. I can stop there, as long as, but that doesn't make sense because maximum point is there. So I need to just sort of maybe come here, close to the x-axis, but not quite. That's fine. And then I'm going to concave down, right? Concave down, and concave down again. And that's it.